Hey everyone, in today's video, I'll tell you 5 key points about mountains. Let's dive in. Mountains are one of nature's most awe-inspiring features, but how exactly do they grow? The answer lies deep beneath our feet. Let's break it down. First up, tectonic plates. The Earth's crust is made up of giant pieces called tectonic plates, and they're always on the move. When two plates collide, they push against each other, and this force causes the land to buckle and rise, forming mountains. For example, the Himalayas were formed by the collision of the Indian plate with the Eurasian plate, a process that's still happening today. That's why these mountains keep growing taller every year. Point number 2, volcanic activity. Mountains can also grow from volcanic eruptions. When magma from deep inside the earth escapes through a volcano, it builds up layers of rock and ash, creating volcanic mountains like Mount St. Helens or Mount Fuji. Point number 3, erosion. Even though it sounds like erosion only wears mountains down, it also contributes to their growth. Wind and water wear away the top layers, but they also carry sediment that gets deposited in other places, sometimes forming new mountain ranges. Point number 4, earthquakes. When tectonic plates move, they don't always slide smoothly. Sometimes they get stuck and release massive amounts of energy when they finally shift, pushing the land upward and creating new mountain peaks. Point number 5, long time. Mountains grow over millions of years, sometimes even tens of millions. It's a slow process, but the Earth's surface is always changing, and the forces that create mountains are relentless. So the next time you look at a mountain, remember that it didn't just pop up overnight. It's the result of incredible natural forces that continue to shape our world, even today. If you enjoyed this video, hit like and subscribe. So after learning how they grow, we're going beyond Earth and into space to uncover the tallest mountain in the entire solar system. Spoiler, it's not on Earth and it's huge. Let's find out what makes this mountain so extraordinary. Mount Everest may be the tallest mountain on Earth, but there's a much bigger one out there in space. Let's head to Mars, where Olympus Mons stands as the tallest mountain in the solar system. Olympus Mons is a shield volcano on Mars, and it's truly a giant. At 69,841 feet, or nearly 21,000 meters, it's about 2.5 times the height of Mount Everest. Imagine stacking 2 Mount Everests on top of each other, and then adding a little extra height. Not only is it tall, but it's also incredibly wide. Olympus Mons has a base that's about 370 miles, 600 kilometers across, roughly the size of the state of New Mexico. And it's surrounded by a giant cliff that's up to 6 miles, 10 kilometers high. So how did this massive mountain form? Well, Olympus Mons is a shield volcano, meaning it erupted in a way that spread lava over a large area, building up layers of rock over millions of years. Mars doesn't have tectonic plate movement like Earth, so the lava could keep flowing, building up this towering peak. Fun fact, the reason Olympus Mons got so big is that Mars has much lower gravity than Earth, allowing massive mountains like this to form without collapsing under their own weight. So, next time you think about the tallest mountains, just remember, Earth's Everest is small compared to Olympus Mons, which stands as the giant of the solar system. If you enjoyed this cosmic journey, answer a quick question: did you hit like and subscribe? Ever wonder why mountains have snow on top, no matter how hot it gets at the bottom? In today's video, we're going to explore why those peaks are always chilly, even on the hottest days. Let's dive into the science behind it. When you look at mountains, one thing is usually clear: those towering peaks are covered in snow, but why? It all comes down to altitude and temperature, and let's break it down. First off, altitude. The higher up you go, the colder it gets. This is because the air pressure decreases as you climb, and air molecules are further apart, which means less heat is trapped. For every 1,000 feet you rise, the temperature drops by about 3.5 degrees Fahrenheit, 2 degrees Celsius. So, even if it's sweltering down at the base of a mountain, the summit can be below freezing, especially if it's at a high enough elevation. This makes it the perfect place for snow to stick around year-round. Point number 2, temperature. The air temperature at the top of the mountain is just too low for water to remain in its liquid form. At these high altitudes, it's often too cold for rain, and any moisture that does reach the peak falls as snow instead. That snow builds up over time, layer by layer, creating the iconic snowy caps we see on tall mountains like Mount Everest or the Alps. And here's an interesting fact. The snow line is the altitude at which snow can persist year-round. Anything above this line will be covered in snow or ice, and anything below it will experience more seasonal changes. So, it's the combination of high altitude and cold temperatures that ensures snow sticks to the top of mountains. No matter how hot it gets down below, the peaks remain chilly. Next time you see a snow-capped mountain, you'll know it's not just for looks. It's the science of altitude and temperature working together. Have you ever wondered why trees stop growing at a certain point on a mountain? In today's video we'll explore the science behind the tree line, and what factors cause trees to stop growing at high altitudes. Let's dive into it. Mountains are full of life, but if you've ever hiked up a high mountain, you might have noticed that trees only grow up to a certain point. This natural boundary is called the tree line, and it's determined by several environmental factors. First, let's talk about altitude. As you go higher up a mountain, the air gets thinner, meaning there's less oxygen available. Trees need oxygen for growth, so at higher elevations, it becomes difficult for them to survive. The tree line marks the highest altitude where trees can still get the nutrients and oxygen they need to thrive. Next, temperature plays a major role. As altitude increases, the air temperature drops. The higher you go, the colder it gets, and trees need a certain amount of warmth to grow. Once the temperature drops too low, trees can't survive, and that's when we see the tree line. Point number 3, wind and weather conditions. High-altitude areas often experience harsh winds and freezing temperatures that can damage young trees or prevent them from establishing strong roots. The constant wind and cold conditions make it difficult for trees to grow beyond a certain point. Another key factor is soil quality. As altitude increases, the soil becomes thinner, drier, and less fertile. Trees require rich, well-drained soil to support their growth, and at higher elevations, this becomes harder to find, which limits the number of trees that can grow. So the tree line isn't just a random boundary, it's a result of a combination of altitude, temperature, wind, and soil conditions that make it difficult for trees to grow higher up. It's nature's way of creating a boundary between life and the harsh conditions found at mountain summits. Next time you're hiking a mountain, take a moment to appreciate that invisible line where the trees give way to rock and snow. It's a clear sign of the power of nature. Enjoyed learning about the tree line? See you in the next adventure. Have you ever wondered how mountains can change the weather around them? Well, in today's video, we're going to explore how these majestic giants can influence rainfall, wind patterns, and even the temperature in their surroundings. Let's get into it. Mountains are more than just beautiful landscapes. They play a big role in shaping the weather in the areas around them. Let's break down how they do this. First up, wind patterns. Mountains act like giant obstacles in the path of winds. When wind hits a mountain range, it gets pushed upward. As the air rises, it cools and condenses, which can lead to cloud formation and even rainfall on the windward side. Now, here's the interesting part. The air that passes over the mountain range and descends on the other side is much drier. This is called a rain shadow effect. So while one side of the mountain gets all the rain, the opposite side may remain dry and desert-like. Point number 2, rainfall. As warm air rises over the mountains, it cools and loses its moisture, which results in rain or snow on the windward side. Once the air gets over the top, it's much drier, which is why areas on the leeward side can be much drier and warmer. Mountains can even impact temperature. When air rises over the mountains, it cools down. On the leeward side, as the air descends, it warms up, causing a significant difference in temperature between the windward and leeward sides of a mountain range. This is why you can have lush green forests on one side of the mountain and arid, dry deserts on the other side, all because of how mountains interact with wind and moisture. And that's not all. Mountains also impact weather systems by steering them or blocking them from moving into certain areas. They create barriers that can make certain regions more prone to storms or keep them dry and sunny. So next time you see a mountain range, just remember, it's not just a beautiful sight but also a major weather player.